Alright, in this video we're going to be solving inequalities, which is something you learn to do in Algebra 1.
Hello, my name is Jake, and your objective is to solve and graph inequalities into interpret solutions of
Equalities.
equalities in set, builder, and interval notation.
Good job.
But you had to tell me a few words and properties. Can you edit that?
Alright, here's all your vocabulary for solving inequalities. There's not really much to it, so pause the video, write the information down, and when you finish, restart the video and we'll go on. Here's something I wanted to throw out there for you. It's common phrases for inequalities. We may have to take like a situation or a word problem and change that into an inequality. So here is common phrases for less than, greater than, less than or equal to, and greater than or equal to. So pause the video if you need to and write this information down. Restart it when you can finish. Alright, so what we're going to start out with is what you started out with in Algebra 1. We're going to start out with one-step inequalities. It's a one-step inequality because there's one math operation there. And we have to undo that one math operation, and we undo it by doing its opposite. So, if I'm adding 4, and I'm going to solve this for y, that means I have to get rid of that 4. I want y by itself, so I'm going to subtract 4 from each side of the inequality. And when I do that, my 4's cancel out here, and I'm left with y is less than negative 16. Alright, example 2. W minus 5. So there is subtraction going on. So in this case, I'm going to undo my subtraction with addition. And I'm going to add the exact same number I'm subtracting. And if I add it on one side, I have to add it on the other. Alright, and negative 5 plus 5, my 5's cancel out, and I'm left with W. I bring down my inequality, which is my greater than symbol, and 24 plus 5 is 29. So my answer is W is greater than 29. Alright, third problem. I have a 12b. Whenever I have a coefficient in front of the variable there, that means there's multiplication going on. So, and to undo my multiplication, I have to divide. And I divide by the exact same thing I'm multiplying by. So I divide both sides by 12. 12 divided by 12 is 1, so I'm just left with 1b. Bring down my inequality. And negative 36 divided by 12 is negative 3. So my answer is B is less than or equal to negative 3. Okay, so my fourth example. It has division, and if you'll notice here, this is negative, so I am dividing by a negative number. So that means to solve this problem, I have got to multiply by that negative number. So I have to take both sides, and I have to multiply them by negative 4. Alright, here's where you encounter the one difference between solving an equation and solving an inequality. Whenever you multiply or divide both sides of the inequality by a negative number, you have to flip the direction of the inequality. Then once you do that, let's see, our negative 4's cancel out because I'm multiplying by negative 4 and dividing by negative 4. And I'm left with an x on this side. My inequality flipped, and I get a negative 28. So my answer is x is less than or equal to negative 28. Our next problem is a two-step inequality. I have multiplication, 2/5 times w, and I have addition, adding 7. I've got to undo both of those operations. And normally when we undo our operations in the solving process, we use our PEMDAS, our order of operations, and we start at the bottom and we work our way up. So that means I'm going to undo my addition first. So I do that by the opposite, which is subtraction. And then I'm left with 2/5 W. And And let's see, let's erase that and move that over just a little bit. So 2/5 W is less than or equal to negative 16. My inequality didn't change because all I was doing was subtracting 7. I was not multiplying or dividing by a negative number. All right, now to get rid of this fraction, I am going to multiply by the reciprocal. Because if you remember from basic arithmetic, if you take a number, you multiply it by its reciprocal, it cancels out and you're left with 1, and that is Plano W. Now because I multiplied this side by 5/2, I have to multiply this side by 5/2. And that gives me negative 16 times 5 is negative 80. And it's negative 80 over 2, so I end up with W is less than or equal to negative 40. All right, the only thing I'm going to do is I'm going to add this. I'm going to add the graph. So first thing I have to do is, you got to remember, whenever you have the greater than or less than symbol, you have an open dot. So this is open. And if you have the greater than or less, the less than or equal to, or the greater than or equal to, it is a closed circle, and it looks sort of like this. You fill it in. So first of all, my starting point is my solution here, which is negative 40. And at negative 40, because that's the or equal to, I have a closed dot. And as long as you have it in this format, you have your variable, your inequality, and your number. Your inequality, you can use it as an arrow that points in the direction you shade. So that means I shade to the left. So there's what my graph looks like. Alright, here's another one for you to do. I would like you to try this one on your own. So, and a hint here on this one, you've got to get rid of that division of negative 3 before you can do anything. So with that in mind, pause the video, solve the problem, and then when you're finished, restart the video and check your answer with mine. Alright, here's what I got. Did you get the same thing? If you didn't, go back and check your work. Two places where you might have made a mistake is when you multiplied both sides by negative 3, you may have forgotten to flip your inequality. And then when you got the variables on one side, and I would try to keep it on the left, because remember it tells you as long as that variable is on the left, your inequality points in the direction you shade on the graph. And when you got to this point right here, there was a negative m, so you had to divide by a negative again, so that flipped your inequality back to the way it started. Alright, here's another one I want you to try. It's going to test your skills on your ability to use the distributive property and to solve an inequality with a variable on both sides. So pause the video now and solve the problem, and then once you're finished, restart and we'll discuss your answer that you got. Alright, if you solve this inequality correctly, you should have gotten 28 is less than negative 27. Your variables should have all canceled out and you're just left with two numbers. Now because you're left with two numbers, you have to look at this inequality here and say, is that a true or is that a false statement? Is 28 less than negative 27? And you should know that no, it's not. So this is a false statement, a false inequality. Whenever you get a false inequality, your answer is always no solution. So you can write down no solution, or you can use the empty set, the 0 with the line through it. And because there is no solutions, you don't graph anything, because the shaded areas on your graph is all the solutions. So if there is none, there's no shading. Alright, so this is our final example here. Same thing, it's going to test your ability to use the distributive property and to solve an equation with a variable on the same side I'm on each side, but here, there is a typo right here. This should be a P instead of a T. So with that in mind, change your T to a P. I want you to solve this problem. And so pause the video and check your answer when you're finished. So pause the video now. All right, once again, everything is simplified down to an inequality, which is two numbers. So let's examine this inequality. I have 24 is greater than or equal to negative 20. Is 24 greater than or equal to negative 20? Yes, it is. So what that means is this is a true statement, a true inequality. Whenever you have a true inequality, your solution is all real numbers. What that means is any number you substitute in will satisfy this inequality. And instead of writing out the words all real numbers, you can use the symbol for all real numbers, which is a bold capital R with a line through it. And what the graph looks like of an inequality that has a solution for all real numbers. Remember, the shaded area on the graph covers all the solutions for the inequality. So in this case, every number from arrow to arrow is a solution. So you shade the whole graph. And that's our review for solving inequalities.